All right, let's talk about linear equations. We have been talking about functions, and you can have a function that's a linear equation. So let's do 3 quick definitions. So first, let's define what a line is. I don't know if I've ever actually given the definition of a line or looked it up honestly that I remember, but it is a straight, one-dimensional figure having no thickness. And lines can consider to be going on indefinitely, but the key here is straight, one-dimensional. We can define that by having an equation. Now, what's the definition of an equation? A statement where the values of two mathematical expressions are equal. So that could be something like 3 plus 2 equals 1 plus 4. Those are equal. And a lot of the times, though, we have to do something where we have something like 5 equals 1 plus x, where we don't know one of them. A single variable expression that you can easily solve. That would be an example. All right, let's look at the definition of now linear equation. You're going to be surprised by this. The equation of a line. Actually, should have been surprised. More specifically, we can say it is a mathematical expression which explains or describes the path of a line. Okay, let's think of a situation. Envision this situation. Now in math, the key thing that we can do is explain a lot of topics in multiple different ways. So let's say I'm taking two steps every second, every 1 second. That's a 1. Now I've represented that in words. Let's say I wanted to make it in let's say I wanted to create a chart. Well, to create a chart, I need to define my dependent and independent variables. Well, time would be my dependent because time would be my independent because independent is going to happen no matter what. And so this is going to be the independent variable, usually x. Steps depend on time moving. I can't take a step without time happening. So this would be my dependent variable. And those are typically your y. So I'm going to put time here, and I'm going to put steps here. Okay. So I'm going to make this assumption now. At time 0, I've taken 0 steps. At time 1, how many steps have I taken? 2. Another second passes. I go to 1 second to 2 seconds. I've taken 2 more steps. So I've taken 4 steps. Time 3, 6 steps. And it would continue on and on like this. And having defined the dependent and independent variables, I can say that this would be the same as the x, and that could be the same as the y. This is always, every time this goes up +1, this is going to go up +2, and it's going to continue indefinitely because 1 step every second. So, do you think we could graph this? I sure do. Oh, look, a ruler I found. Full 30 centimeter ruler. Okay. Let's draw this in a blue line. All right. Now I'm going to have this a little unbalanced only because I have the space and I'm only focusing on positive values. So, draw my axes, label them x and y. This is time in seconds, and this is steps. And I would start at 0. And I have 1 second, 2 seconds, 3 seconds, 4 seconds, and it would go on and on. Let's say 1 step, 2, 3, 4, 5, 6, 7, and that could go on as well. All right, now if we were to plot this, what would it look like? Well, I would take my x value and I would find it, there's at 0x, and I go find my y. And I go up to my y, well it's just 0, 0, so it will be my first point right there. x1, so I find 1. My y is 2, so I go up to 1 to 2. 2 and 4, so up to 4. Now I will again reiterate, this is not drawn to scale. 3 and 6, so 3 up to 6. And I have a projection of my line. I don't have a limit set on it, so this line is actually going to go indefinitely. And I really should say, because it's based on time, oh my goodness, making a mess. Because it's based on time, I can't go into negative time. So I could say my line looks like this. I could graph my linear equation. All right, now, in mathematical terms, this looks great, this looks great. The sentence, not as much. We can't always put it in a sentence in other stuff and work with it. So the question we want to ask ourselves is, can we create an equation? Can we write an equation for this line? And the answer I hope that you have is yes, we can. So what would that look like? Well, What do you guys think? How do we figure it out? You can try to determine an equation from this. Or what we can do is we can work with some other known forms. Yes, we can. Yes, we can, but we need a few pieces of information. The one thing we really need is the slope. Now, slope is a very important concept that you're going to use a lot of the times moving forward in math, especially dealing with lines and science. So what is slope? Well, slope is the rate of change of the line. The ratio of the vertical change or rise to the horizontal change or run of a line segment Okay, new piece. Y-intercept. And what is the y-intercept? It is the y-coordinate of the point where a line or curve intersects, crosses the y-axis. This can also more simply be known as the value of y when x equals 0. The value of y when x equals 0. Okay, so the slope and the intercept. How do we, well, that part's easy. How do we find slope? Finding slope. Okay, well, how do you find slope? Well, I said it's the ratio of the rise over the run. So slope is equal to rise and over the run. Now the ratio is set out in this form. Slope is commonly represented with an M. with a letter M. So I would say that my slope is M equals my rise over my run. And how do we calculate rise? Rise is the change in y from start to finish. The change in y moving left to right. Across a graph. And it's commonly referred to as delta y, which is y final minus y initial. Similarly, run equals the change in the x value moving left to right on a graph. That would be the same as saying delta x is equal to x final minus x initial. Actually change these just so we don't get confused to y2 minus y1, and we'll graph this out and take a look at it. So I could actually say that the slope m is equal to delta y over delta x, and delta is the symbol, the Greek letter delta, and it means change in some value. Okay. And then, of course, this would equal, y2 minus y1 over x2 minus x1. And I wrote this wrong. x2 minus x1. All right. Let's get me a sheet of graph. Okay. Let's take a look at this. So I have made a graph here with my x-axis, 0 to 5, and my y-axis 0 to 5. I've left out negative numbers. They of course exist and are there, but I'm not worried about them. Okay, so what I want us to focus on is where these 2 points are, and I want to figure out the slope, or how the slope rises in this case. Okay, so I'm at 1, 3, and I'm at 4, 4. I want to know how far up I go for how far over I go. Okay, well, the rise would be identified as, going up this way or over this way. So I went up a value of 1, here to here is 1, and I go over 1, 2, 3. 1 over 3. So my rise equals 1 unit. My run equals 3 units. So that means my slope, which is the change in y over the change in x, is going to be 1 over 3. So I go up 1 for every 3 steps forward. Okay? just a minute. I'm gonna go draw another one. Okay, so I've graphed a few more charts. Let's look at this one in the top corner here. I guess I should label these 1, 2, I'll work down here, 3, 4. Don't worry about 3 and 4 yet. Let's just look at 2. So let's draw our graphs and let's plot some lines. And I'm not going to give these specific numbers. Okay, so there's my points. Graph my line. And theoretically, my line is continuing indefinitely. I set no constraints on it. And now I'm just going to say, so this was over, let me make sure you can see it. This was a specific case. I had specific points, so this is specific. And over here, let's just do a general so we can see where we get that equation from. Okay, let's say I call this point x1, y1. It can be any number. And up here is our second point. x2 minus y2. Whoops, comma y2. x2, y2, and x1, y1. Okay, so, well, let's pretend we're plotting out and counting up. We're going up, 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 up. We're going up from y1 all the way. So this would be the y value of y2, x1. So the difference between the x1 point and this one, this line's going to extend all the way this way, magically. This would be x1, y2. So what's our change in the rise? Well, to go from this point to this point, let's just jump back over here for a sec. So this point here, I said this is 1, 3, and this is 4, 4. If I go up here, I'm at 1, 4. This point right here is 1, 4. Okay? So this one, instead of 1, 4, this is going to be x1, y2. So I'm going up here. So what's my rise? Actually, I'm going to work it over here. My rise is going to equal whatever y2 is minus whatever y1 is. Because y2 minus y1, the difference of the height here. What about my run? Well, my run is going to be from here, x1, all the way over here to x2. I'm following the same line. I'm going straight across, and I would have to go from x2 to x1. x2 minus x1 is the difference of my run. So for a slope, I get m equals y2 minus y1 divided by x2 minus x1. Let's do this again. Okay, let's do another general one. Let's say I'm just skip counting by 2's. 2, 4, 6, 8, 10. This is x. This is y. 2, 4, 6, 8, 10. And that would be continuing that way, those are irrelevant to me. And let's say I'm starting here at a point 2, 4. Okay, let's say my next point is all the way over here at 6, 10. On the radio. Gorgeous line. Look at that straight line. And that's what we want, a straight line. The rate of change of a line. So, what's this actually telling me? Well, I want to look at my slope. So I want to see how high it goes up and how high it goes over. Okay, if I go up here, I'm starting at 2, 4. I'm going all the way up to 2, 10. This point would be 2, 10. So what's my change in my rise? Well, I went to 10 from 4. So my rise is 10 minus 4, or 6. What's my run? My run is going this way. I start at 2, I went to 6. So final minus initial, 6 minus 2 equals 4. So my slope m equals 6 over 4. Now I should report that in a reduced fraction, 3 over 2. So this is another specific form. Now let's do another general. y2, y4, y6, y8, I don't want to do that. Two, 4, 6, 8, 10. 2, 4, 6, 8, 10. That's a y, that's an x. So, let's say I don't specify the points. I just say, I don't even need the numbers here. Let's say I start here at x1, y1. And I go all the way up here to x2, y2. So I have my straight line. Okay, here's my line. So what am I looking at exactly? Well, I have a rise going from here, x1, y1, going up, 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 and then I go a run. So I have this special point here, which is going to have the value x1, y2, because y2 falls along this y value. So what is my rise going to be? Well, I'm going up from x1, y1 to x1, y2. The only thing that changes is y1 and y2. So my rise equals y2 minus y1. Now my run, I'm going across. I'm starting at x1, I'm going all the way over here to x2. My y stays the same, y2, y2. My x changes, x2 minus x1. I don't have actual values, I just have my equation m equals y2 minus y1 over x2 minus x1. General equation for the slope of a line. Can't put a cap on that pen. Now, slope can have a few different characteristics. Slope can have a few characteristics. Slope can be positive. Okay, let's say I start with the line here at 2, 3, and I go up to 4, 9. What is my slope going to be? My slope is going to be 9 minus 3 over 4 minus 2. Six over 2. Or 3 over 1. Or just 3. I have a slope equal to positive 3. Signs make a difference. Positive slope as you move, as x increases, y increases. Additionally, okay, let's say I'm starting here at 0, 15. And I end over here at 2, 5. So my slope obviously looks different. As I go from left to right, my y value is decreasing. So in this case, I'm going to look at my rise. At my starting point here, my rise is going down, 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 and over, 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 over for my run. So my rise m equals, well, my delta, y2 minus y1 over x2 minus x1. Well, I have a y of 5 minus 15. And I have an x of 0 to 2. So 2 minus 0. 5 minus 15 is negative 20 over positive 2, so I get negative 10. M equals a negative 10. This is a negative slope. As x increases, y decreases. Two more types of slope. I guess I'll name this 2b. Draw this line. Slopes can also be This is all stuff you'll recognize for science, so please pay attention to this. And if you bared with me this far, send me an email that tells me your favorite stone fruit. Alright, so I have this line here, 0 to 5 on the x-axis and 0 to 5 on the y-axis. Let's say at 1, I'm right here. And then at 5, I'm here. So my points are 1, 2, 5, 2. Okay. Connect the dots. Connect the dots. So, is there a change in my y? There's no rise. Well, I guess I could look at it. What's my x values? 2 minus 2. What about my run? Well, I go from 1 to 5. So 5 minus 1 is 4. So what's my slope going to look like? 0 over 4. 0 over 4. Let's just equal to 0. This has a 0 slope. As x increases, y remains unchanged. Okay, one last one. So I can get here before my wife gets here with the weed eater. I know I haven't worked with negative numbers yet. I just want to show you the basics before I start adding in negatives and you're subtracting negatives and it's confusing and you're frustrated and you don't want to do it anymore. Don't worry, you'll get to that soon enough. Alright. So I've done lines that have positive slope. I've done lines that have negative slope. And negative slope anywhere along a graph. Positive slope anywhere along. 0 slope anywhere this way. One more type is this type. So let's say I have a point that is 1, 1. And then I have a point that is 1, 5. Let's draw this line. Magic. Oh man, right through my y. Alright, there. Up and down line. Well, what's my rise? Well, my rise is I'm going from y1 to y2, so 5 minus 1. Or 4. What's my run? Well, I'm not going left or right. But let's subtract our x's. 1 minus 1. What's 1 minus 1? 0. So what's our slope? 4 over 0. Any fraction with the denominator of 0 is undefined. That's 0, is undefined. We can't give it a value. We can't divide by 0. I can't have 4 apples and not divide them by 0. I can't give them to nobody, not even myself. That doesn't happen. Okay, any fraction with the denominator 0. So we just call this undefined. And this is an undefined slope. And what is that is, there's no change in x. It doesn't matter what the y is doing. No matter change in y. Bam, boom, done. Okay. Well, where does this bring us, Gaffney? Good question. You know, I might stop there for now, and I might go find some work for you to do, practicing slopes before I do the rest.